Hi everyone. So here is an application called as watsonx, which we have developed as a service bot to answer Watson related queries. So to curate and prepare data efficiently for any GenAI use case, it's important to consider the following points. First is data selection. That means in what format your data is, depending on the kind of applications. Second is data representation. So in most GenAI application, data has to be represented in high dimensional vectors, considering the modality and unstructured format of your data. Third is vectorization, the method where it converts the unstructured set of data into AI model readable format. And the final is vector database, which is nothing but a specialized database tailored to handle the high dimensional vector data. So to build our service bot application, what we need to consider are these three buckets, that is data storage and database, AI models and APIs and integrations. Data storage, when we talk about, it is nothing but to store our vector representation or high dimensional vectors data. AI models in order to do this Q&A or summarization or intent classification kind of operations on your data sources, and API integrations finally to integrate your final application to the UI or to the final chatbot applications. So we are able to achieve this acceleration and scaling of our application using watsonx.data and watsonx AI integration. Today we have this additional capability in watsonx.data, wherein the new data source is a vector DB called as milvisdb. Milvisdb is a vector database which helps us store the high dimensional vector data, and using watsonx.ai, then we will be able to do all of the different use cases like question answering or doing the generative AI summarization task, or even understanding the entities or classifying it using the data which is getting stored in the Milvis database. So what we are doing here is a simple RAG application, that is RAG with watsonx AI, and integrating it with watsonx.data featuring Milvis. RAG is nothing but a retrieval augmented generation AI framework which helps us retrieve the facts from an external knowledge base, which is the additional layer for the large language model to get the most accurate and up to date information for the end users. If we think about the persona based actions which are to be taken in our application, in terms of data scientists here will completely leverage the foundation models available on watsonx.ai platform. It can then do different operations like classifying articles, generating insights, doing any key extraction of the details, or answering the specific questions. So in terms of data engineers, they'll enable our easy access to the data by establishing new schema and table dedicated to the data leveraged by watsonx.data. They will help us orchestrate the loading process, seamlessly ingesting the articles to the designated Hive table within the watsonx.data. They'll then create the vector embeddings of the data which is sitting in the watsonx.data and then insert them to the Milvis vector database. Thus, all of this meticulous handling of these data sets for the streamlined downstream tasks are facilitated by data engineers. Now let us look at our architecture diagram of our final product. So here we see that we have different users like foundation model developers, prompt engineers, and customer or end users who will directly handle the UI or the end user application. So users will ask the kind of questions from the chatbot and want to have the answers. So what the overall data which is from where the answers are to be fetched is sitting in watsonx.data. In watsonx.data, if you see Milvis database is getting leveraged, which is the additional data source in watsonx.data. The data once curated is then stored into the object storage, which is nothing but again the additional low cost storage of watsonx.data. Once we have all of these data curated and available in a vector embeddings format in milvisdb, watsonx.ai here can can be used to ask the queries using different LLM models. So this is how the overall architectural layout of our application looks like. These are the different PDFs which I am inserting in watsonx.data and then doing the vectorization and saving it into Milvus vector database. So I can ask these different kind of queries which are residing in this data source. So you can see there are this whole documentation talks about the frequently asked questions in of watsonx.data. I also have inserted one more documentation, something like this, wherein it gives us the watsonx capabilities of watsonx.ai capability, watsonx data capabilities, and so on. So let's now insert the records into watsonx.data. Let me insert these PDFs and then ask the questions against these different PDFs. So now my application is running. Once it gets uploaded, we will see the messages uploaded PDFs. Now it is connecting to the watsonx.data and Milvus vector DB. Now I can ask the question against these PDFs, which are my corpus. Let me go and ask here the query as this only, watsonx.data. Okay, so I would want to know what are the capabilities of watsonx.data. So you see, we get the answer in a very crisp format about including AI/ML at scale, building trusted AI/ML models, streaming data engineering, reducing data pipelines, and so on. All the real-time analytics and BI, combining or ensuring compliance with lineage, and all of these different pointers are there in our PDF as well. Here we are getting is a more abstract output of the complete data which is sitting in our PDF. Similarly, we can have one more question like what is data lakehouse? This is how we get the complete abstractive output. Here it has pulled us exactly the same answer which is sitting here. So thus leveraging Milvus DB in watsonx.data, we leverage this capability to query against the unstructured data sources and also optimize the performance by using fit for uh, format engine like Presto. Thank you.